Hey guys, it's Josh K here. I'm going to be doing question 4 of that paper we're doing. I'm first going to show you guys the question, and then I will go through the solution with you guys. So let's get this question started. The vertices, ooh, I like this already. The vertices of a square have coordinates p, 0, 0, w, comma, x, y, comma, z, and q, comma, 0. So these are the coordinates of a square, guys. The vertices of a square have coordinates, yep, where all variables used are positive. Hooray! We need to prove that p plus q is equal to w plus x plus y plus z divided by 3. Divided by 3. Guys, you got that? You got this? This is the fourth question that I was offered to answer. Yeah. Prove that p plus q is equal to w plus, yeah, all this. Now, guys, pause the video if you are not sure if you want to do this. Try and have a go with it. As I say, if you want to have a go, just try it out. Post your answer in the comments. If you want, you can watch the video completely, look at the mark scheme, and post that if you want, and I will totally believe that you did it yourself. Yeah, so it's an option. You can either be honest and actually have a real go yourself, or you could just pretend you've done it by looking at the mark scheme, and everyone will believe you as well. That's another advantage. Okay, let's think about this. Before we start any question, you must think about the question. The vertices of a square have coordinates p0, w, x, y, z, q0. So we know that these 2 points are on the thing. So I'm just gonna paintbrush open. Whoops. Let's try that again. Paintbrush. That was a good size, wasn't it? It was. Okay. Good. Cancel. I don't want that. Okay, let's drag that along so it's in the correct zone. And I like organizing my desktop, guys. That's good. Okay. The vertices of a square have these coordinates. So let's create the thing that should do, and that should do as well. Okay, now what do we know? What do we know about this square? We know that it's one of its point is at p0, so its x coordinate is p and its y coordinate is 0, and it also has a coordinate like that. So I'm going to try my best somewhat square. Try about square. It's about a right angle, I think. It's not a bad right angle. Not too bad, I've seen worse. Especially from this angle, it's not that easy. About it. There we go. That's the square, guys. Pretend it is one. Pretend it is one. So we know that a point P, that's obviously on the horizon because there's y0. So we know it's point P must be here. And we know that point Q must go there. And we need to prove something. So let's get another text edit out. Today it's not good. File, new, go down there. Don't destroy Microsoft Word. It's a good software, guys. Okay, let's do this. Don't need this to be so big. It's just a question we need to prove. Okay. Okay, what do we know about this shape? Actually, just try and have a go at this in the exam room. I never got time. Okay, we know that it must be looking like this because all values are positive. And we also know that the gradient between this and this is going to be the same gradient between this line and this line. And this line and this line are also going to have the same gradient. And so those are some of the facts we know. So let's go through this correctly. These angles are ordered in this rotation. So it was ordered counterclockwise, anti-clockwise, counterclockwise. I always thought anti-clockwise, and then here in this country is counter, or is it in America? I don't know, guys. Okay, so P is 0. Yeah, so then we know that this coordinate must be W, comma X. Place that there, and that coordinate must be Y, comma Z. And there we go. We got everything we need. Everything we need. Now let's just get some equations out. So we know that the gradient comes in like okay, I haven't memorized my equation, so I'm just going to do some bit of organizing. You know that m is equal to y change divided by x change. So we know that m is equal to y1 minus y2 divided by x1 minus x2. Okay. Now let's work this out. So there are two gradients in this equation. There is gradient m, and I'm going to rename the other one n, because that's the next letter after m. There's this gradient and this gradient. So let's get the y1s substituted. So m is going to equal, what's y1 minus y2? So that's basically this gradient. What is P's y1? So it's going to be 0 minus Q, 0 minus Q, divided by, and then it's going to be P minus 0. And that should give you the thing. I'm going to just cancel that out to P, this to negative Q, so you get minus Q divided by P. That is the gradient. You can see that there. But we also know that this gradient is parallel to this gradient, so we can cancel that even further. So we know that this m is going to be equal to y1 minus y2 again. Let's cancel this out. What's y1 in this equation? Remember, you're going to keep your thing. I'll take this one as the 1. So it's going to be y1, so it's going to be x minus z. X minus z. And then w minus y. And okay, that should be correct, guys, isn't it? Yeah, it is. So that is the gradient of this, and we know that these two must therefore be equal. Come on, copy, come on, paste, copy, equals, come on, paste. Yeah, I'm gonna just redo that, guys. Come on, paste, equals. Just drag that down. Get rid of that. This is gonna give that. So this is M. So this equation is needed. Now let's get N out of the way. So there's two N's we need to discuss. One N is this, and the other N is this. And because it's a square, oh, forgot to label the square bit, the square part of the square. It's all right angles, hooray! We got it right. We got it. You got a square with all right angles, and a bit of a dodgy right angle there, but yeah. It's meant to be correct, and it's just a diagram just to help our brains work. So now let's work out what y1 minus y2. Now remember, any point you can choose because you just have to negative it out. So let's let this point be 1 and this point be 2. So 0 or 0 minus q. Actually, this would be 0 minus q or something like that. So it's going to be 0 minus the z. 0 minus the z. I think it is 0 minus the z. Please tell me I haven't got this wrong. Oh, wrong. 0 minus z. And it's going to be q minus y. And that should work out, guys, because as you can see, this is going to return a negative number. This is going to return a negative number. I can actually multiply everything by -1. So that's just going to be z. And this is going to be y minus q. So that is equation 1, or first n sorted. Still gonna need that bracket. Get rid of the spacing so it just seems closer together, like a friend. Yeah, there we go. That's organized. That's what you call organized equations. Now let's get this equation out of the way. We know that. Let's let this point be number 1. Actually, let's let this point be number 1. So we know that x minus 0, x minus 0 is x, and then w minus p. That should be right. And let's just check it this way as well. Z minus 0, y minus q. Yeah, that works, that works. And again, we know that these are equal. Hooray! Somewhat hooray. So let's just, come on, copy. Come on, paste. It's equal to this one. Good. So, we've got two lovely equations. Come on, copy. Come on, paste. So we know all this stuff. And, okay. What we kind of need to do is realize that -1 reciprocaled gives you the thing, gives you the equality. So this equation's a bit messy. These equations are a bit rusty.